The first, we start from the chapter review. Chapter review is on page 1, and the first section, real numbers. The real numbers. First, we review the concept so-called sets. Sets. A set is a well-defined collection. Well-defined collection of distinct objects. Distinct objects. Okay, so in this definition, this is like the definition. In this definition, we have two important words. The first is this well-defined. What does this mean? Well-defined means for a set, we know an object is in or not in this set, Okay, so there are only two situations for an object, for the relation between an object and a set, in or not in. This is a what so-called well-defined. There's no gray area, like say, I'm not so sure if it is in or not in. That is not possible for the set. You should be clearly sure it is in or it is not in. So that's well-defined. Distinct means in a set, no objects repeat. Okay, so in a set, you will not have repeated element. You will not have repeated element. So that's a distinct. Every two elements or every two objects are different. Okay. If a set, so you see here, it's a well-defined collection of distinct objects. If every object does not belong to the set, or the set contains no element, it makes sense. So no elements repeated. All the objects are distinct in the set, and it is well defined. Everything will be outside of the set. So it is a set, and this set is special. It is called an empty set or the empty set. Empty set means nothing inside. Empty or null set. Null set. And for the empty set, the symbol is this. You put a 0 and an extra segment. Okay, so later whenever you see such symbol, it means it is an empty set. No elements or no objects belong to this set. Okay, so that's the abstract definition. Let's see the example. So there's several ways to show a set or to present a set. For example, I can put D to represent a set, and this set is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a set of all 9 digits. The set of all 10, all 10 digits, just digits, 0 up to 9. There's 10 digits, and we list all possible object of the set. So this is one way, and you use brace to include them. You use braces to include them. Okay, and the other way to represent set is to show the property of the objects. So for example, this D can be written like this. So we always use the braces to demonstrate a set, to show or present a set. So we first present this object, we use X to represent this object. And we put a vertical segment. And after vertical segment, we're going to write down the property of the object. X is a digit. And the other part of the brace. Okay? So X represents an object. This object should be a digit. If the object is a digit, it belongs to the set D. Okay? So in the book it says, you can read it, D is a set of all X. D is the set of all X such that X is a digit. Okay, we know that what number is a digit? 0, 1, 2, 3, 4, 5, 7, 5, 6, 7, 8, 9. So this set D is identical to this set D. The same thing. Okay? Yeah. And yeah. So this one is like you list the name or list all the element. So they give it a name called the roster method. Roster method. Okay, and this one, this type of thing, they call it the set builder notation. Well, don't ask me why they give such name. It's just a name. Set builder notation. So there are two ways to present a set, to show a set. Okay? Okay, so next, let's see the example. Let's see the concrete example. For example, if we want to, so here is this the example of set, and then we have another example of set. We use a set builder notation. Set builder notation, E is a set of all X such that X is an even digit. This is one way to present a set such that X is an even digit. What digit is even? 0, 2, 4, 6, 8. Right? So they are the even digit. This is a roster method. This is a set builder notation. I mean, you don't have to know memorize the name. For different textbook, these two names are not the universal name. For different textbook, they may give the different name, but you should understand the idea. And this is like a special setting, like builder notation. This one is just the list. Sometimes you may say they call it the listing method, whatever. And the other example will be O is a set of all X such that X is an odd digit. Odd, even odd. So you will have 1, 3, 5, 7, and 9. It's even par, impar. I assume they are in Spanish they write this way. Okay, whatever. Okay, if I know how to say it in Spanish, I will write it down. If I don't know, I will just use the English version. Okay, so when we say what a set is, we say it is well defined. We say it contains distinct object, but we never say they have order. There's no order about presenting a set. For example, if we write 1, 2, 3, we have this set. We can also write it like 2, 1, 3, or even 3, 1, 2, whatever order. We only care the elements, the objects, but we don't really care the order when we simply represent a set. But we cannot repeat, so we don't write it this way. This is not correct. You cannot repeat elements. Set just simply get those distinct elements. Okay? Okay, so after those examples, we see that the set of E and the set of O, they are both just part of D. So if every element of a set A is also an element of a set B, we say A is a subset of B. Write A subset of B. A is a subset of B. So if every element of A is an element of B, then A is included, is a part of B. Then we write A is a subset. It has to be every element, not just some of them. So for example, here we see that E is a subset of D. We use those examples. E is a subset of D. O is also a subset of D. But E and O, they have no relation. They have no relation, okay? And for this type of stuff, you see, if two sets, A and B, have the same elements, we say A equals B, of course, right? Right. A equals B. So if we call this set A, this set B, then A is equal to B. If we call this set A, this set B, then they equal to each other, right? Yeah. Okay. Next, another definition. Let A, B be two sets. We have two sets. The intersection of A and B denoted A intersect B. Okay, so we have a new definition. An intersection is the set consisting of elements that belong to both A and B. It's inside A, also inside B. That is called the intersection, the overlapped part. The union, this is one definition, intersection. And second one, about two sets. The union of A and B. Denoted A cup, A union B, is the set of not of, consisting is a set consisting of elements that belong to either A or B or both. It belongs to one, it's enough. It belongs to both, well, it's okay. We do not exclude that case. Okay, so this is the union. This is notation of intersection. This is notation of a union. Okay, whenever you have two sets, they may overlap, or two sets can have the join of two sets, right? So let's see the example. So we let A be 1, 3, 5, 8. B 3, 5, 7. C 2, 4, 6, 8. Well, usually we use capital letter to represent or to denote a set. Smaller regular letter to represent an object inside the set. Okay, that's just convention. Okay, assume we have those three sets, A, B, C, D, E, F, G, whatever. First, let's see what is A intersect B. A intersect B, you just check which elements or which object is repeated. So you see here you have 1 in A but not in B, so it's not intersection. 3 is in A and in B, so it's a intersection element. 5 is repeated. 8 is not. 7 here is also not, so that's done. So the intersection A and B is 3 and 5. Okay. A union B. What is A union B? It's either in A or in B or in both. So if you want to write down the A union B, first you just copy every element from A. You copy every element from A because they're in A. And then you see which element in B is not in this list. So 3 is already copied. 5 is already here. 7 is not here. So you add this 7 from B, missed. Okay? So this 7 is not in the previous list, it's just copied down. So this is a union B. And C, B intersect A union C. Well, this is very complicated. Of course, when you have intersection union, you can get some iterated process. You get A union B, and then intersect C, and then union B, whatever orders, a method. So in order to find B intersect A union C, first, C1, you need to find A union C. You need to find A union C. A union C, what is A union C? You just get everything. 1, 3, 5, 8, and see 2 is not copied, 4 is not copied, 6 is not copied, 8 is repeated. Okay, so that's one way to, this is the first step. You first find A union C. It has bracket, no, parentheses. It has parentheses, so you have to compute this part first. And then second step, you get B intersect A union C. Intersection, you just get B is a 3, 5, 7. A union C is a 1, 3, 5, 8, 2, 4, 6. So 3 is repeated, 5 is repeated, and that's all. So you're going to compare it here and here. So B intersect of A union C is 3, 5. See? Okay, so that's about intersection and union. Okay. Next. In the first example, see here, in the first example, we have D. It has all digits, and we have E and O. E is the even digits, O is the odd digits. So E and O, they are both inside the discussion of a D. D represent all digits. It's like the universe we're talking about. We only talk about digits, then D represent every possibility. Then inside inside this universe, we are talking about the even digits. We're talking about odd digits. We're talking about this, and we're talking about that. So from here we get a definition. If A is a set no, not here, sorry. We should write this. In working with sets, we usually, or in our mind, sometimes we may not even write it down, but usually we designate a universal set. A universal set, we call it U, universal set. What is a universal set? The set consisting of all the element that we wish to consider. So when we were kids, we will possibly consider the universal set, like if we're talking about the numbers. When we were a kid, we will possibly consider universal set as like the natural numbers. We will count 1, we will count 2, we will count 3, we'll count 4 and 5 and 6 up to 10, and later 11 will be too hard, and so we'll have universal set. And after we study a little bit, we will see I want half pizza, we want a quarter, we have a quarter something, and then we will see we have the rational number, the ratio, right? 3 over 4, 5 over 7. So in that moment, the universal set becomes a set of all P over Q. Right? In that kind of case, we will study the universe. We will, in our mind, we'll believe every number will be either a integer, a natural number 5, 6, 7, or maybe it is like a half, a quarter, or 3/4. Then universal set becomes a set of all rational numbers, positive rational numbers. And later, possibly in 5th or 6th grade, we see there's negative numbers. Of course, we already learned 0. And then there's a negative numbers. So there's -1, -2, -quarter, -half. Then in that moment, our universal set becomes a set of all positive and negative and 0 rational numbers. And in the high school, we'll see there's square root of 2. It's irrational. So we'll have rational plus irrational number. Then the name is called the real numbers. So even though in different time, in different age, we will have different universal set, but at one moment in your mind, whenever you talk about a number, you actually have a range. That biggest range is this universal set, right? Yeah. So in the fourth grade, you will never consider the irrational number. Whenever you talk about a number, it will be a rational number. So that is the universal set in your mind. It's not written down, but it exists. Okay, so that's a universal set. And with this universal set, let A be a set, another set, a set, the complement, a complement of A denoted A bar is the set consisting of all the element in the universal set that are not in A. In the universal set, but not inside A. So this is called the complement. No, called complement. So be careful. The element in the complement of A is definitely not inside A. It's definitely not inside A. But this complement depends on the choice of the universal set. For different universal set, the complement might be different. Okay, so whatever, let's see, we have the complement. Let's see the example. So whenever you talk about complement, you must clearly write down the universal set. Let U be 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 digits. Be the universal set. Okay, so we have a universal set like this, and A is odd numbers. A is odd numbers. Then what is A bar? The complement. Whenever you see this, this is complement. Sometimes in other textbook, they may write like this, A complement. So for different textbook, you need first to check the notation. In this textbook, we use A bar to represent the complement. In different textbook, they may use A C to represent the complement. The same thing. It means it's inside U but not inside A. So they are 2, 4, 6, 8. Again, I write it in the ascending order, but it's not essential. We just need to include all those numbers. Okay? Okay. That's a complement. If you change this universal set, definitely the complement will be changed. This U is different from the D we discussed at the beginning. D we mean all the digits including 0. But here we only represent the 1 up to 9, no 0. Then the complement does not include the 0. And from here we will see that if you get union of A and its complement, it's definitely equal to the universal set. You get a union of them, it's definitely equal to the universal set. If you get intersection of A with its complement, it's always empty. There's no element. It belongs to A and also belongs to the complement. No way. It's either black or white. Okay? So there's no gray area. Okay, so that's the universal set and the complement. Again, a complement depend on this universal set. You change the universal set, you change the complement. So every time when they ask you to write down the complement, you must clearly see what universal set you select. Okay, so in the discussion of elements, we have a useful tool. It's called the Venn diagrams. Venn diagrams. What is a Venn diagram? Venn diagram is used to discuss the universal set, complement, intersection, union. So usually we just draw a rectangle, slightly large rectangle. This rectangle, this region will represent the universal set. Okay, so we have a universal set. Any element we are considering will be inside this rectangle. And we will draw a circle. Usually we draw a circle to represent a set. This is a set A. A set A is in the universal set. Okay, and of course, you may have set B. You may have set B. So if you draw your set B like this, you see those two regions do not overlap. Then when you draw this, you want to represent a situation. The intersection is empty. The intersection is empty because they are not overlapped. And if you want to present two sets overlapped or intersected, you will draw something like this. If this way, then this overlapped region is the intersection. The overlapped region, you use shadow to represent the overlapped region. This is intersection. And you have A, you have B, then the union will be all the parts shadowed, covered by A and B, like those two potatoes. So this is A union B. A union B. This is A intersect B, A union B. And the other one, if this is A, then this part what is this? This is complement of A. It's inside the universal set, but not inside A. So this is complement of A. It's a Venn diagram. It's a Venn diagram. Okay. So that's the first subsection of the section review part 1. Okay. So in this part, what we discussed the set, well-defined collection of distinct objects. We have examples, and we have more examples. We emphasize in the set, the order of objects is not important. And then we discuss a subset. Let me put it down here. We discuss a subset, and we discuss 1, 2 sets are equal if they have the same elements. And then we have intersection. We have intersection. We have union. This is an example about intersection and union. And after that, we have this universal set and a complement. Universal set and a complement. And then we study the Venn diagram. We have intersection, union. Let's see. For example, this is A. This is C. So this shadowed part will be, let me get, this shadowed part will be A union C. Shadowed part A union C. And then we get B. Remember that we had an example exercise about A union C and then intersect B. Then what is that part? It's this part. See? You see the process? So first I get A union C, and let me make it. Yeah. First I use pencil to get the shadow A union C, and then we use a ball pen to emphasize where is a B intersect A union C, like these two parts. Right? Okay, so this is a Venn diagram. Oops. Okay, good. So it's very important, very, very important, and very useful to demonstrate. Okay, so we stop this video. We're not finishing the class. We stop this video and we will continue the discussion in the second video. Thank you.